Hello guys. Welcome back. Thanks for showing interest in the video tutorials on www.logicvoltage.com. This is the 5th tutorial on the video tutorial series on interfacing LCD with STM32F4Discovery board. In this series we are learning how we can interface a LCD and display on it using STM32F4Discovery board. You can check out the website www.logicvoltage.com. In the website, there are many other STM32F4Discovery video tutorials. You can watch them and learn. You can even check out the video store at the website. It has some good tutorial series there with very less price. Lot of peoples are buying it. You can also buy them and learn some very awesome things about embedded programming. You can even get in touch with us also. Just go to Contact Us page and fill up the form, and we will reply. You can even check out the forum also. For any tutorial related query or any technical questions, just create a new topic in an appropriate forum and write your questions and doubts. And we will reply you there so that other people can also see the comments and what discussion is going on. Thanks. Okay, so in the last tutorial, we have written the font file for 95 characters. And then we have configured and initialized the FSMC peripheral. Now in this tutorial we will write the remaining code for initializing the LCD properly. Actually, just by configuring the FSMC peripheral, the LCD will not work. We have to actually write on some LCD registers first, before we can actually display something on LCD screen. So now we will write on those LCD registers. Now if you remember, in the third tutorial of this video series, we have already discussed how we are going to write on LCD registers. For writing on LCD register, we will actually write the register address and data on a particular memory location on the internal memory on microcontroller. And FSMC will automatically transfer that data to the LCD register. Now first we will define those two memory locations. Okay, so here you can see that we have declared two memory locations. First one is LCD_reg. And second is LCD_RAM. LCD_reg points to memory location 60 million. And LCD_RAM points to memory location 60,020,000. And these two locations are actually in the internal memory of the microcontroller. And why we have chosen these two locations, that also we have discussed on the third tutorial of this series. Now when we want to write some data on a particular LCD register, then we will write the register address on the LCD_reg location. And the data, we will write on LCD_RAM location. And rest FSMC will take care. Now next thing we will define here is Here we have defined two fixed values. Max_x is 320. Max_y is 240. These values actually represent the maximum number of pixels on LCD, on a particular axis. In X direction we have maximum 320, and in Y direction we have maximum 240. Now there is one issue here. You might get confused that in which direction of LCD we are assuming X, and in which direction we are assuming Y. Let's now understand this. Let's say we have the LCD module here. Now first let me show you what's the default configuration on the LCD. Now you can see that in this direction our X-axis works. And in this direction the Y-axis works. Now the maximum value that X can hold is 240. And maximum value that Y can hold is 320. Now why we are discussing here X and Y? What X and Y represents? Actually here each X and Y point represents one pixel. Hence if I say for example, go to X40 and Y90. Then this point will represent 40 and 90. And in this way we can go to any pixel and do something with that pixel. Now you can see that by default the LCD works in portrait mode. But we want to display in landscape mode. Let me show you what we wanted to achieve. Now this is default configuration. Now our custom configuration will be. So you can see that X and Y axis got changed. Here to differentiate the things, we have shown the LCD default configurations, in red color. And the configurations we want, is shown in green color. Now in this landscape mode, the maximum value of X can be 320. And maximum value of Y can be 240. Now there are few things which need to be understood here. Actually LCD will always work in default mode. And we actually, never be able to change the X and Y axis. So question is why we are showing you green lines, if the red lines are fixed and cannot be changed? Because we want to display in landscape mode. And it is always preferred that, top left corner should always be the first point, that is X is 0 and Y is 0. That's why we are discussing this topic here. Now as I told you that LCD will always works in default mode and it cannot be changed. Hence by default it will take the bottom left corner to be the first point. But we want the first reference point to be the top left corner. So to achieve that, we have to do some calculations. Actually what I meant is, we will write a function. And we will pass our X and Y values to that function. And that function will actually convert. That function will convert our X and Y values to the LCD default configured X and Y values. And this conversion has to be done by using this formula. Here you can see that X is calculated on the basis of Y value we have passed. And Y's value will be X directly. Basically what we are doing here is, we have to find a way that will convert our X and Y values to the LCD default configured X and Y values. So that both actually represent the same point on the screen. Otherwise if we don't do this calculation, and directly pass our values to LCD, then LCD will actually represent some other pixel, and we will get wrong display. Now let me show you an example. Let's say we have LCD here. And these are axes. Red colors are LCD default axis lines. And green colors are our axis lines that we are assuming, and will use. This is the formula that we will be using. Now let's say we have send, x, 80, and y, 150. So we want to make this point black color. Now as you can see, which point we are referring here on the LCD screen. But if we directly give these x and y values to LCD, then it will represent a different point, because its axis lines are different than what we are assuming. So this will be wrong. That's why we are converting the values here using the formula. Now after the conversion, we got x89 and y80. So now when we will pass these converted x and y values to LCD, the LCD will actually represent the exact point which we wanted. Hence you can see how this thing is working. Actually this is an extra step here. Because if we work in portrait mode, then we can directly work. But here we want to display on landscape mode, hence needed this extra step. Okay, so now I hope you understood the process here. Let's now get back to the program. Okay, so now we have seen how we will actually do the conversion of x and y values. And we have to write a function that will do the conversion. But we will write that function a bit later. Now next is here we have defined some color values that we can use. Now you might be asking that how these color values came? How these values represent a specific color. For this we need to open the datasheet of the LCD. Okay, so here we have the datasheet. Let's go to page number 26. Okay, so here we have section named System Interface. In this we have a table having 3 figures. This first one is the one that we have to use. Here you can see that we have 16 bits. These 16 bits actually represent 1 pixel. And these 16 bits actually represent the color of a single pixel. Now we are using RGB interface. That means we have to represent a color using red, green, and blue color. And if you see here, red color is represented by 5 bits. Then green color is represented by 6 bits. And then blue color is represented by 5 bits. And then LCD will convert the 16 bits into RGB color. So basically we have to write these 16 bits, and give it to LCD, then it will be converted to color using this way as shown here. That's why we have written these hexadecimal numbers for each color. Because each hexadecimal number actually represents those 16 bits. And when we give this hexadecimal number to LCD, it will be converted to color by the LCD. Actually, if you go online and check for RGB, then you will find a lot of topics where you can understand how mixing different quantities of red, green, and blue can produce different colors. So same I have written here. Okay, so now we have defined different types of colors also. Now next is Okay, so here we have defined three functions. First one is LCD_write_reg. This function is for writing some data on a particular LCD register. In this function we are passing two parameters. First one is the LCD register address. And second one is the data to be written on the LCD register. Now if you see closely here, we are actually passing those data to other two functions. Second function is the LCD_write index. This function is actually writing the LCD register address on the memory location that we have defined, LCD_reg. And this is defined in the top as you can see. So whatever the LCD register address, that address is going to be written at this memory location. And then we have the third function named LCD_write data. This function is actually writing the data on the already defined memory location, LCD_RAM. So as a whole you can see that first function is actually calling the next two functions one by one. So whenever we want to write any data on any particular register on LCD, then we will call the first function, and pass the register address and the data. And that function will automatically call the other two functions, and write the register address and data on the internal memory of the microcontroller. And then FSMC will automatically write the data to the specified register on the LCD. Hence in this way we can write to LCD. Now we can start writing on the LCD register, and configure and initialize the LCD properly. Let's start now. First is as you can see that I have written in the LCD_initialization function, below the LCD_pins configuration function call. because in this we are writing all our LCD initialization code. And we are actually calling the LCD_initialization function from the main function. Okay, here I have written a line that is calling the function LCD_writeReg, and passing two parameters. First one is the register address on which we want to write. And second is the data that we want to write. Here we are writing to LCD register address 3. And we are actually making the 12th bit on this register to bit 1. Let's open the LCD datasheet also, so that we can see side by side all the registers. Let's go to page number 52. Okay, so here you will find all the LCD registers one by one along with their purpose. Let's go to register 3. Okay, so here we have that register. Its name is entry mode. And you can see the 12-bit is BGR. And we are making that bit to 1. Now go a little down. And you can see that BGR1 means, swap the RGB data to BGR and writing into GRAM. That means that we want the RGB data to be written in BGR. Actually it has many configurations. And if I go to each and individual detail, it will take a complete different video series and which is a completely different topic. Hence here we are just initializing the LCD so that we can display something on LCD screen. Now next is okay, let's see this register on the datasheet. Okay, this is the register C. Here we are actually selecting the 16-bit RGB interface, because that's what we are using. Now next is here we are adding some delay of approximately 50 millisecond. This delay is needed as per the LCD datasheet. Now next is here we are configuring the power control 1 register. Here we are configuring 4 things. First thing is adjusting the constant current in the operational amplifier circuit in the LCD power supply circuit. Second thing is enabling the power bit. Hence start the generation of power supply. Then third thing is selecting the optimal step-up factor for the operating voltage. And fourth one is source driver is enabled. Now what individually each means, that you can easily read from the datasheet. Now next is here we are configuring the power control 2 register. Here we are configuring 3 things. First, set the ratio factor to generate the reference voltages. Second thing is, selects the operating frequency of the step-up circuit 1. And third one is, selects the operating frequency of the step-up circuit 2. Then next is adding a delay so that LCD is properly powered up. Then next is Here we are configuring the power control 3 register, and setting up some values. Then next is again adding a small delay. Then next is here we are configuring the power control 4 and 7 register. Then next is here we are configuring the frame rate and color control register according to our requirements. Then next is adding a small delay. Then next is here we are configuring the gamma control registers. You can easily go to LCD datasheet and look into the description of these registers and read yourself. And you will understand. Then next is again we are adding some delay, so that LCD gets some time to adjust itself according to the settings we have done above. Then next is here we are configuring the horizontal and vertical RAM address position registers according to our requirements. Then next is here we are configuring the gate scan control registers. Then next is here we are configuring the panel interface control 1 register. Then next is Here we are configuring the panel interface control for a register. Then next is here we are configuring the display control 1 register, and then adding a small delay. Now it is done. After all these LCD registers configurations, our LCD is now properly initialized and ready to display. Okay, so this function LCD_initialization is now complete. And this function will completely initialize the LCD for display. Now next thing is, we have to write a function that will set our LCD cursor. If you remember, we have discussed this earlier in this tutorial, that we will write a function that will do some calculation and convert our x and y coordinate values to LCD-specific x and y coordinates. So let's write that function. Okay, so we have declared a function named LCD_setCursor. And it is taking two parameters. One is x and other is y. Now let's write its function body. Okay, so here you can see that first we are calculating the LCD-specific x and y values. And then we are actually writing those x and y coordinate values to LCD registers. We are writing x value to register 20. And we are writing the y value to register 21. If you go to LCD datasheet, then you will find that these registers are GRAM horizontal and vertical address set. Hence, using these two registers, we can put our cursor to any pixel coordinate. So this function is complete. Now next is, we need to write a function that will make all the pixels on the screen of a particular color. That means if we made the whole screen of LCD of green color, then this function will do that. Let's write that function. Here we have declared a function named LCD_clear. In this function we are passing one parameter, that is color. So whatever the color code we pass in this function, it will make the whole LCD screen of that color. It is first setting the cursor to 0, 0. Then it is writing the register address, that is 22. And then it starts writing the data, that is color, using a for loop. We are using this for loop because it will keep incrementing the pixel coordinate from 0, 0 to 320, 240. Hence, one by one pixel, it will completely make all of the pixels on the screen of the same color. Here you can see that we have written the register address once, but we are writing the data every time for each pixel. That's because if you read this register 22 description from the LCD datasheet, then you will understand that, writing to this register, and then writing to GRAM data, LCD will automatically increment one by one this register value. Hence we do not need to write every time. Hence we can continuously write the pixel color code, and LCD will automatically increment the pixel one by one. Okay, we are almost done here. In the next tutorial we will complete this program and run it and see the output. Okay, so in this tutorial, we first understood how X and Y coordinates are calculated, and how we can display in landscape mode. Then we have started writing code for initializing the LCD. After this we have written some functions for changing the background color of the LCD screen. Okay, in the next tutorial we will continue further, and finish this program, and run it on the discovery board. And then we will see the output. Okay, once again this is from www.logicvoltage.com. And thanks for watching. Bye.